Anything else? What was your question, Aldwin?
I'm trying to remember, is Pluto bigger or smaller than our moon?
Oh, Pluto's small. Okay, which planets have planet-wide magnetic fields? I saw some people waffling on this one. We had, let me just list them out here. We had this in yesterday's lecture, the summary. Remember, on this test, you're going to have to know the planets in order, plus some, you won't know which aspect about those. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. That's the order. You have to have that order. And now for each one of these, let's look at the magnetic field. What do we know about the strength? Well, let's start with the Earth. The Earth has a surface strength, I tried to change the color, there, of 0.5 Gauss. That's the surface strength. Everything else we're going to say just compared to the strength of the Earth, which is actually not talking about the surface strength anymore, but about the total magnetic field. So Mercury, the first one. Does anybody remember how strong the Mercury magnetic field is? Very, very weak. I think it's 0.06% of Earth's. It's either 6% or 0.06. I think it's 0.06. So a very weak planet-wide magnetic field on Mercury. That was shocking. It was assumed to have none because Mercury is small, should have cooled interior relatively quickly. The fact that it does have a planet-wide interior then leads scientists to believe its core must not be frozen like they had assumed, probably because of its, being close to the sun and getting a lot of heat still. Venus, what do we know about Venus's magnetic field? It's what? Imasen. Imasen is Japanese for it doesn't exist. So what do scientists conclude by the fact that Venus has no magnetic field? They say it's got to have molten conducting material, so it must be, and even though it's rotating very slowly, computer models say that it should still have a measurable magnetic field from that, so it must be not having convection. Mars, what does Mars have? It has traces frozen in. Like our seafloor has traces of magnetic fields frozen in. It doesn't have a planet-wide magnetic field. And the question was planet-wide. And so that's why it fails. It just has the remnants of a former planet-wide magnetic field. What about Jupiter? I'm like my mom, Look up to see if anyone's with me. 20,000 times the Earth's magnetic field. That is a behemoth magnetic field. Saturn? I'm glad you said that because I wasn't confident, but that's what I thought it was. So I'll take the fact that we both remember the same to be correct. So Saturn, 500 times Earth's magnetic field. Uranus? 47. And Neptune? Right. So all of the outer planets, all of the gassy planets have magnetic fields. Of the inner planets, Mercury and Earth do, but not Venus and Mars. And we talked about the things that we identify for the ones that don't have them. For Jupiter and Saturn, they have magnetic fields, but they believe those really strong magnetic fields couldn't be coming from inside of the cores. They must be from further out. And so it's conjecture then that it's conducting liquid metallic hydrogen that's swirling around above the water layers in Saturn and Jupiter that's making their magnetic fields. And then Uranus and Neptune, remember how wacky their magnetic fields were? And so scientists conclude, okay, they shouldn't have liquid metallic hydrogen in them. So it must be a briny, water, salt waterish, swirling around with ice chunks that creates its crazy, wicked magnetic field. So the correct answer, looking at all this, all but Venus and Mars. And finally, for our last question, what is the Great Red Spot? Most of these were ridiculous if you remember anything about Jupiter. Question, Alwyn. Oh, okay, go ahead.
It's the cyclone storm.
A cyclonic storm. What's ridiculous about a mountain on Jupiter?
It's a gas.
Yeah, there's no surface. You can't have a mountain without a surface. It does stick up like 50 kilometers, but it's a cloud. It's not a mountain. Okay, depression on Jupiter. What doesn't make sense about depression on Jupiter?
Doesn't have a surface.
Yeah, it doesn't have a surface. Now, you could say, well, it could be depression in the clouds, but the cyclonic storm goes up anyway, so it doesn't make sense. A sea on Jupiter?
Doesn't have a surface.
Yeah. Those first three were ones that I was hoping wouldn't distract many people, but they do make you think about what you have there, and we don't really know. Every now and then there is a question that's the answer, but we do know in this case. Any questions about the quiz? Did you guys do good on this quiz? Yeah. That's the goal. Excuse me?
I don't remember what I answered.
Well, the goal is for you guys to score well, of course. The goal is for everybody to learn, be happy, and the Raiders to win the Super Bowl. Those are the only goals I have for this class.
I don't think that's what everybody wants. I think that's what you want.
Those are the people who are mistaken. Okay, so today we're going to finish up. Today is the last material that will be on the test next Friday. So we'll finish up today. On Monday, I believe I will review. On Wednesday, Aldwin and Russell and Hannah and Amelia? And Max. They'll review. They'll do their student presentation. Then Friday we'll have our exam. So hopefully we'll get to the rings and comets and meteors. Comets, well, that's not a comet. That's a comet, yes. They're cool. They have two tails. You can see one, the ion tail, one, the dust tail, and we'll talk about those in a bit, maybe. Real quickly going over the other moons. Now, we'd already talked about Io, right? Skip that. Europa, I believe we went through that. Callisto and Ganymede. You can see that the two of them here. Actually, didn't I go over this one too? Yeah, so I'm just going to pass over it. We did not talk about Titan. Saturn's moon Titan is Saturn's largest moon. Not the largest one in the solar system, but Saturn's largest. And it's bigger than Mercury, right? Mercury's small. It has a thick atmosphere, so 50% higher atmospheric pressure than on Earth. That's not bad. It wouldn't be crushing to us. We couldn't breathe it because it's 95% nitrogen, whereas we have 79% nitrogen. And of course, we have 21% oxygen. Clearly, it doesn't have oxygen there. Part of the problem with that is, 95 kelvins is just a little chilly. Now, nitrogen won't be forming a liquid until you get down into the range of 70 kelvins. 77 kelvins is the temperature of liquid nitrogen at 1 atmosphere pressure. So there it's a higher pressure, so it'd be, a little bit different, but very cold. So, you could have some ponds of liquid nitrogen. We're not going to go swimming in those. So it has rivers and lakes of methane. That's a gas on Earth. And it's very flat. Its largest mountains are only a few hundred yards tall. Now, that is taller than the largest mountain in the city of Lincoln. You guys know we're standing on top of the tallest mountain in the city of Lincoln, right?
Because Prescott, the highest point elevation-wise in Lincoln.
Yeah, because Peanut Hill is and Peanut Hill is the name of this.
So much.
Here, what was that?
That explains so much.
Yeah, this is Peanut Hill, and that's why we have the Peanuts theme on campus. Okay, so Saturn's moon, Iapetus. It's really cool. It's got a dark side and a light side. It's kind of like, the yin and yang.
So the moon is an actual dark side.
Yes, it has an actual true to life dark side. Not dark because of if it's lit up or not, but because one side is dark. It's tidally locked, and the leading edge is the dark side. So the theory is that basically it's gone through and collected debris on that leading side, and that's why it's dark.
I mean, it doesn't be yin and yang if it had like a white spot on the dark side.
That's okay. We're good with it the way it is. Saturn's moon Enceladus, or I always like to think it's a salad. It has geysers of water, just like in Yellowstone Park. Its energy comes from gravitational forces. So if you look at it, it seems a whole lot like, let's say, Europa. You've got an ice surface that looks fairly fresh, just a few pocks, and you have geysers because of the gravitational working. Miranda is awesome in my opinion. Look at this feature right here. Something has gouged the heck out of Miranda.
It almost looks like an eye.
The theory is that it must have had either a serious collision with something that just scraped it, like in Star Wars, you have a big ship that's maneuvering, yeah, that kind of action, or that it could have strong tectonic activity that broke the surface. But it's kind of a cool moon, so just looking at the moon. And I think this is the last one I have, Neptune's moon Triton. It's larger than Pluto. Pluto, very, very small. It orbits backward relative to the rotation of Neptune, which is probably a good indicator that it didn't form with Neptune, that it was something that was captured by Neptune. Because if it formed with Neptune, it should be orbiting the same direction that Neptune is rotating. Its atmosphere freezes on the night side of the planet. So you have air during the daytime, during the nighttime, it disappears because it freezes. Pluto actually is similar. Pluto has an atmosphere when it's close to Neptune, it'll get an atmosphere. It goes further away, the atmosphere freezes and snows down. Okay, so our first question, which moon do scientists think is most hospitable to life? This is not a question from today. Well, actually, it kind of is. We didn't talk about it. But it's what we have talked about previous days. There we go. All right, everybody's in. Now, this is one that you either know it or you don't know it, so I'm not going to poll the class on it or have you discuss it. 5 people said Europa, and those 5 people are correct. What about Europa makes scientists think that life could be there? This is a thought question. Okay, it has water. They believe that underneath its icy exterior, there is a sea. And besides water, what else do you need for life? Not an atmosphere. We have things that can live underwater, like fish. But they need an energy source. We tend to think we need sunlight. But there are things on Earth that can live in places where sun doesn't reach them as long as they have an energy source. So it needs to have an energy source, and they believe that there are vents letting thermal energy come out of the core to heat up the water. And so you should have those 2 things for life. Now, you have to have certain elements for life. There's more than just those 2 things. But those are considered the 2 hard to get things. Why do scientists look for life on Mars? Because they think Mars could have had water in the past, gets the sunlight. It could be habitable for life as well. Now looking to Pluto. Pluto has a large moon, Charon. Now I say a large moon. Remember, Pluto is very small compared to other planets. Well, I shouldn't say other anymore. I'm just, I'm old. Compared to planets, Pluto has a small size. But Charon is large compared to moons if you take things in scale. Charon is what? Something like 1/3 the mass of Pluto. So it's very significant size compared to Pluto. Charon orbits in a very tipped, it's not in the same plane. Remember, our moon, it's only 5 degrees off the plane of its orbit around the sun. Charon is steeply tipped. There have been more moons found so that we now know of 5 moons of Pluto. So you have Nix and Hydra. Then you had Kerberos. And finally, Styx. So those are the moons. Except for Charon, they very much look like asteroids. Charon looks like, a sphere. Gravity pulled it into a sphere. Here's the statement about the orbit. And Pluto is just one of a large number of icy bodies beyond the orbit of Neptune. A very primary reason why scientists wanted to demote it. Because they realized Pluto is not special. It's one of probably hundreds of similar objects. And so if we open up our planet definition to all of these, we have an unmanageable number of planets, and it becomes an insignificant title, and yet we have some real significance to things like Saturn and Jupiter. So they didn't want to water down what it means to be a planet. So what we knew from Pluto, this is what we knew Pluto looked like until a year and a half ago. Actually, it was about a year and 3 months ago. That's the best that we knew that Pluto looked like.
Was that before the probe went?
Yes. But then they had the probe that went by. Now we know Pluto looks like this. A much different picture. And so that probe, we're still getting new information every day because the probe took all of its pictures and all of its sensors were whirring away. And then I think they say it's going to take 5 years for it to transmit all of the information to Earth. So we're still getting information about what Pluto's really like from that. And so there'll be new discoveries. This is one of the things about astronomy. You really have to update the textbook very regularly because what we know is changing very regularly. To that end, I know this is a boo point for you. The textbook that I helped to edit it's now available, and so I'm going to be using it next year. It's an online free textbook. I know. They disappoint you because you can't sell your book back.
Dang it.
But it's a free online textbook that I'll be using. And being an online textbook, they will just go through a yearly update cycle, so it will stay reasonably fresh with the new discoveries. Question, Alden?
Yeah. So if they found life on a planet like Pluto, would it change its classification back to a planet?
No. Because remember, the classification is based on, does it have enough mass to bring itself into a spherical shape? Well, that's a yes. Does it have enough mass to dominate its neighborhood, to clear it out? That answer is no. And so they've made a definition that's very specific and that it won't qualify for. Max?
Isn't it kind of a redundant definition because it has enough mass to clear its space? Wouldn't it have to be large enough to be spherical?
I believe it's not purely redundant because it depends on how close it's orbiting to the sun for the clearing of space, I think. I could be wrong on that. It could be purely redundant. By the way, what does this look like right here? I stopped there because different people have different, yes. Some people look at this and they see a heart. I look at it and I see Snoopy, So it depends on you, but it's an interesting feature there on the surface of Pluto. And of course, before this, nobody knew anything about any surface features. One of the things that they discovered with these pictures is that there is less atmosphere of Pluto than they had thought. And because there's less atmosphere, Pluto is actually a little bit larger than they had thought. But because it's a little larger than they had thought, it's less dense than they had thought. All of these things, one after the other. We don't know that much about things, and this is inside our solar system.
That's why everything's a theory.
That's why everything's what? A theory. Okay, so here are the best pictures we have of the moons. I guess I should show Karin first. There's Karin. This, once again, comes from the New Horizons probe. We didn't have anything close to that resolution before. What'd you say, Russell? Almost looks like the moon, yes. But it's an icy thing. It's not a rocky thing at all. And you can see from the date here, July 14 is when it flew by. And then we have...
It passed by?
Yeah, it passed by Pluto on July 14 of last year,
So what's it
2015.
doing now?
It's heading out to another trans-Neptunian object. I don't remember which one they chose. Not to Eris, because Eris is just too far away.
How long did it take? Like, what, about 70 years?
No. To get out to Pluto? No, it took somewhere in the ballpark of 7 years, I think.
7 years? Not too bad. 70 years would be cool.
Okay, so these, if you look at them, Styx, Kerberos, now those are very fuzzy pictures, but they're just little rocks. You look at Nix and Hydra. Nix and Hydra are bigger rocks. Now I say rocks. I actually didn't check to see if they were ice or if they were actual rock. Much more likely that they're ice than rock, given their location. They're much more likely to be ice chunks than rock chunks. I didn't check that, and I now feel bad that I didn't. This picture here, I believe, is a... Well, no, it's not. It's just these are both pictures of Pluto. I was thinking it was something else, but it's not. Okay, question that I just answered. Make sure we're remembering. Why was Pluto demoted from planethood? Why did I fail English? It has a moon that is 1/8 of its own.
What?
Yes, that one doesn't make sense. Just don't answer that one.
I thought John was like the
Getting your answering, Jessica? Okay. What were you saying, Russell?
I thought Sean was like the
That's what I said. And I thought that was, well, yeah, I thought it was 1/3 the mass. Maybe it's 1/3 the diameter. I did check that number. But this one here was clearly wrong because of its own, it doesn't say what. There was one person that said there are moons larger than Pluto. Are there moons larger than Pluto?
I mean, our moon is larger.
Absolutely. Yes, our moon being one of them. But that's not the reason it was demoted. It wasn't just because it was small. It was, well, the philosophical reason, because there were lots of things like that. But to get a reason that they could make, okay, here's the definition, and this definition excludes it, the definition included has to dominate its orbit, and it doesn't dominate its orbit. There are lots of objects that have that same 3-2 resonance, a lot of objects orbiting in the same range. Okay, now we go to ring systems. And when we do ring systems, we always have to start with Saturn because Saturn's the one that obviously has rings. So Galileo Galilei first saw the rings of Saturn. But what he saw would look nothing like this. What he saw, I think I had a picture earlier, basically looked something like that. Just, little fuzzy things out to the side. But he observed that there was something going on there. And then Christian Huygens noticed that you had structure in these rings, that they're detached from it, that they're not actually part of Saturn itself. Now, keep in mind, back in Christian Huygens' day, this is long before we had telescopes of the quality we have today, they tended to think that these objects were all like Earth, a solid surface. And so the idea would be that you have a solid surface with a solid disk that's going out with it. And Christian Huygens noted, no, that's not the case, that it's separated. And then Maxwell realized that the rings themselves were not solid, but were made up of particles. That's James Clerk Maxwell. And so now, as we understand it, we have different rings with divisions. So this outermost ring is the A ring. And then we have the Cassini division, which you see right there. And then we have the B ring. And then we have the crepe or inner ring right here. So there's our C ring. So we have these rings. But careful analysis shows there's a lot more detail than that to be observed. Now, this is, of course, not real color. But here you can see a lot of structure in those rings. Do you remember what I said causes the structure? Okay, they have to do with the moons. There are two things. One is the orbital resonance. Same thing when we talked about the Kirkwood gaps. You have orbital resonance that causes the Encke gap is, I'll put it here in green. So the Encke gap is this one here, and then Cassini's division is this one. Okay, that was a horrible choice of color. This one here is Cassini's division. Those are caused by orbital resonance, just like the Kirkwood gaps in the asteroid belt. But then other structures are caused by things like small moons acting as shepherds. So the small moons come around and they keep material bound kind of between them. And if you look at these things, you see, well, where do I have it? This picture over here. Totally cool. That's a ring. Now, this is a ring around Uranus, not a ring around Saturn. But what do you notice about that ring? Well, what you're supposed to notice is not that it's flat. And not that my hand is shaky, but that it's braided. It's going like this. And that's caused by shepherd moons. In this case, you can see a shepherd moon up here, the 1986 U8 and 1986 U7. And those two moons together are causing this braided action in that ring. Is that cool or what? All of the gas giants have rings of some type. But those rings are not like the rings of Saturn. These are made out of material that basically you can only see when the sun's behind them and the light coming through the rings is obstructed by the sun. So they're hard to see. The size of particles here, the largest particles in Saturn's rings are house size. The smallest ones are little tiny pebbles. The largest are house size, and it depends where you are what the size is. And so I believe the colors here are actually referencing the size, but basically you have your largest objects out here and your smallest objects in here. These here are all small, tiny things, whereas this was, changed to a dark color, this was ice. This stuff here is dirt. It's stuff like what Durs made, silica and carbon type stuff. So it's a different type of material. Where would ice stuff come from?
Comets.
Ice stuff would come from comets. Where would dirt stuff come from? Rocks, asteroids. So different source for the stuff that's in the rings. And now we can come back to what I said about the lifetime of rings. Rings don't have a permanence to them. They're transitory. And so if we still have rings, that means that they were formed sometime recently, as scientists would call it. And so scientists conclude that you have things that because of gravitation, some object comes by, pulls something a little bit, it hits something else, its orbit gets all screwed up, starts falling at a crazy angle, comes close to a planet, either gets captured to become a new moon, or gets too close and gets inside that Roche limit and gets shredded and then becomes a ring. And so the process will continue to make more rings. So, who knows? In a year, we could get lucky and Jupiter could have some big icy object come too close and get shredded and have nice, big, glorious rings. Right? We can't predict. So here is the discussion about that Roche limit. This picture, I believe, is a picture of, what's the name? Shoemaker-Levy. There's a number with it. I think it's 9, but I'm just going to leave it Shoemaker-Levy. A comet that was discovered by Shoemaker and Levy that got too close to Jupiter. And if it gets inside that Roche limit, if it gets so close that the gravitational force, we call it a tidal force because it's how strong it is as a function of distance. If the gravitational force going from here to here caused by Jupiter changes by more than the gravitational force between these two pieces, it will pull it apart, unless it's glued together in some way. So if I have ice, a chunk of ice, a cube of ice could survive because it's kind of glued together, right? It's molecularly bonded together. Whereas if it is a snowball, then it's just compressed together, it would be pulled apart. So it depends on the type of material. But if it's something that is just compressed together and it gets inside that Roche limit, it gets torn apart. So this comet got too close to Jupiter and it got torn apart. And then the pieces went plummeting into Jupiter, creating a very exciting show. Max?
Theoretically, could the Earth have rings, or does it have a Roche limit, or is it too small that the objects would have to get too close and get in the atmosphere?
That's a really good question. I've never calculated. You can calculate, it's not that hard, where the Roche limit would be, and I've never done that for Earth. I think that Earth, the Roche limit doesn't exist, but I don't know. Yeah.
Actually, I was reading an article, and apparently one of Mars' moons is supposed to fall into it, so it shouldn't.
I haven't said it, so I can't say yay or nay.
But then Mars will get
Then Mars would get what?
wings. No, the moon's going to perform being close enough so that tell the asteroid to come and make that run.
Oh.
So Mars can have it.
If Mars has a Roche limit, then Earth must, but I don't know. Okay. Last, before we get on to cool, by the way, you guys do know, in case I don't get there, the Orionid meteor shower is going on right now.
The what?
Orionids. Well, meteors are supposed to be the last topic today. I just want to mention that before I forget. So, trans-Neptunian objects are objects that are beyond the orbit of Neptune. That is, their semi-major axis is larger than the semi-major axis for Neptune. Have to specify that because Pluto is sometimes closer than Neptune. Pluto's sometimes closer than Pluto would make no sense. Sometimes closer than Neptune, sometimes farther. But its semi-major axis, or its average radius, is farther than Neptune's, hence it's a trans-Neptunian. Plutinos is a special category of objects that are in 3-2 resonance with Neptune. Pluto is the largest of the Plutinos. Hence, they're called Plutinos after Pluto. But it is not at all the only Plutino. There are lots of objects that are in the 3-2 orbital resonance with Neptune. So it's interesting to know that we have these TNOs, these trans-Neptunian objects, Plutinos being a special category of trans-Neptunian objects. There's also cubanos, QB1-like objects is what cubano stands for. Another interesting type of object that I am not going to talk about. But I will talk about some of the largest trans-Neptunian worlds. So these objects, all but, well, which ones of these are minor planets? Or dwarf planets, if you will. Okay, Pluto's a dwarf planet. What else?
You could put on.
Those are the dwarf planets, I believe, right now. Eris, most certainly, should be a dwarf planet. Actually, yeah, maybe it's Eris instead of Sedna. I think it is. I think it's Eris that is the dwarf planet. There are 4 dwarf planets out there. It's been proposed that all of these should be dwarf planets, but they haven't been accepted yet. Charon here is kind of a specialty because Charon is the moon of Pluto. But if you look at Charon's size and compare it to these, it's of similar size to Sedna, Quaoar, and Orcus. So if it is accepted as a dwarf planet, then we would have Pluto and Charon are a dwarf planet binary system, which is another cool thing to think about. Notice the semi-major axes for these. Eris has an average radius that's 80% larger than Pluto's. So it gets way out there. It also has an eccentricity that's much larger than Pluto's. Way, way out there. It also comes in closer than Pluto. So there will be a time when Eris will be pretty obvious in the sky. That time is just not now. Sedna is really amazing, both because it has a huge semi-major axis and a huge eccentricity. Now, if you're going to plot the orbit of Sedna, it really is something like that.
Wait, that's the sun.
Yeah, the sun is the little dot there. And so it's a pretty outstanding orbit. Okay, let's move on. Comets. Comets are named comets because they look kind of like commas. They have the head, and then they have the tail. But it's more complicated than that. First of all, you have the nucleus of the comet. The nucleus of the comet is essentially an ice ball. Now, ice and rock is what we say because the densities, it depends on the comet, but they tend to be somewhere about the same density as Pluto, which we believe to be a combination of ice and rock. So many scientists will call them dirty snowballs. Dirty snowballs, combination of ice and rock. Well, if it's far away from the sun, it's just hanging out there as a dirty snowball. But if it gets close to the sun is hot. And so the sun will cause the ice to melt, and the solar wind, all of the charged particles blowing off of the sun, plus radiation pressure, the pressure that light puts on material, pushes all of that debris, the stuff that boiled off, away from the sun. And so the tail of the comet is pointing away from the sun. It's not a tail telling you where it came from. It's just pointing away from the sun. Now this tail, question? Okay. The tail, stuff that came off, it could have ionized material, like, let's say, a hydrogen atom. That's probably not what it is, but maybe water with an electron that was kicked off. Or it can have neutral stuff like little pieces of dirt. And so the neutral stuff, the little pieces of dirt, that's called the dust tail. And the ionized stuff is called the ionized tail. So the charged ionized tail, that interacts super strongly with the charged particles leaving the sun. And so it points virtually directly away from the sun. The ionized tail always should point directly away from the sun. The dust tail doesn't interact as strongly because charged particles don't affect it. So it's relying on just the pressure, things hitting it. And so it generally is pushed away from the sun, but not as strongly. So in the picture that we started with, you saw the two tails separated. The ionized one would be directly away from the sun. The other one would be trailing somewhat behind, but mostly away. Notice the tail can be hundreds of millions of kilometers long. Right? You get a lot of stuff blowing off. It's all out there. So here's a picture of Comet Halley where you can actually see the nucleus here. and you can see stuff being ejected rather forcefully from that nucleus. Here's a picture of the comet Wild 2. I guess we should say Wild 2, right? If we're going to pronounce it the German way. This here, we're just seeing the nucleus when it's not giving off a bunch of gas. I think I've talked about this actually enough. I'm going to go on to the picture here. You see the sun is this direction, so the ionized tail directly away. Dust tail, so it's probably traveling something like that. A nice picture to illustrate it. I don't think there's any words you really need to have with that after what I've said. When it's far away, no tail. Why no tail when it's far away?
Because it's away from the sun.
Yeah, it's so far away from the sun, it's not melting. It's not sublimating, which is going directly from ice to gas. You get closer and you have sublimation, you start making a tail that's going away from the sun. Notice there's all this debris in the dust tail. That debris is important. We have, I should say this. I told you this at the very beginning of this section. Now we get to at the end of the section. The evidence for the Kuiper Belt and the Oort cloud was originally just looking at the comets, saying, okay, the comets must go really slow when they're way out there because of what we understand of Kepler's laws. And so going really slow out there, they spend most of their time out there. There must be some region out there with lots of icy objects. And so the ones with shorter periods were in the same plane as our orbit. So Kuiper said there must be a belt in our plane. The ones with long periods come from all different directions. And so Oort said there must be further out just a spherical shell filled with these icy objects. And so the Oort cloud is believed to have somewhere around 100,000 astronomical units out for its maximum distance, way out there, pretty much to the edge of what we consider the solar system. Okay, so now meteor showers. Last minute. We have a meteor shower that's going on right now. What does that mean? It means that the Earth is passing through a cloud of debris. Where did that debris come from? A comet. So the Earth is currently passing through the debris left by a comet many, many years ago. Now, astronomers try to track where all the clouds of debris are so they can predict what's going to happen now. Which cloud are we going to go through? How big is the cloud? How exciting is the meteor shower going to be? When you have a meteor shower, the meteors appear to come from one location, which we call the radiant. Why that one location? That's not the picture I want. That's not the picture I want. Okay, I guess I don't have the picture I wanted, so we won't go with it. Why one location? Because the Earth is orbiting around the sun. And the direction we're headed is going to be the direction that they appear to be coming from, because we're just crashing into this debris cloud. And so right now, the fact that we have an Orionid meteor shower means that right now the Earth is headed in the direction toward Orion. Now, Orion is not visible at sunset right now. It's visible a couple hours after sunset. Doesn't mean you're not going to see the meteors, but when you see the meteors, they're going to be appearing to come from the eastern horizon early in the evening. Later on, they might appear to be coming from higher up in the sky. You'll see them go in both directions. But we're just passing through this debris. How big do you suppose this debris is? I've said it before, but not today, I don't think. Like the size of a grain of sand. You have these tiny particles the size of a grain of sand just hanging out in a cloud. The Earth comes and slams into them. Well, it doesn't matter if it's the Earth moving or the debris moving. If you compare the two, the speed of that debris relative to the Earth is really fast. And so just like the space shuttle burned up when there was a problem entering the atmosphere, that's what's happening with these little pieces of debris.
Didn't it burn up on its way in the atmosphere?
One did. One burned up on its way back. One blew up on its way out, one burned up on its way back. But these little sand-sized things, they come into the atmosphere, they get ionized. Now that they're ionized, they can affect things farther away. They're going so fast that they transmit a lot of energy, raising the electrons to higher energy states and molecules as they pass. Electrons fall back down and give off the light. Just 3 words to end the day. Meteor. A meteor is the light you see shining through the sky. As the meteor occurs. A meteorite is the object that strikes the ground. A meteoroid is the object that's out there before it comes into the Earth's atmosphere and becomes a meteor. Almost every meteorite is a piece of an asteroid. But almost every meteor is cometary debris. How can those two sentences make any sense?
Well, because it could be stuff that's stuck in our atmosphere, in our orbit.
I didn't quite make it out, but because I'm already over time, I'm going to give the answer, assuming you were right. The cometary debris burns up in our atmosphere and never makes it to the surface. So the stuff that makes it to the surface, which we call meteorites, is only the large things like asteroid debris. So meteorites tend to be asteroid because that's all that can survive in the ground. Meteors tend to be cometary debris because it makes it to the ground. Okay, we're done for the day. Oh my goodness, I'm sorry I went 4 minutes over. Well, 3.5.
Doctor, did you say 4?
Well, 3.5.